Okay, we're solving ordinary differential equations by separation. Let's just have a quick look. This is question 3a, dy dx is equal to x plus 3y, and I want to get down to y is equal to something. So to get rid of my dy's, I can integrate both sides. So if I try to integrate this straight away, I got in problems because I have x's here and I have y's here, and they're all mixed together, so it's not a simple integral. So it's not the most basic type. Next thing we might do is the separation of variables. Apologies, I have separation up here. I actually meant it's substitution we're going to be doing today. But let's try and do the separation of variables. Okay, we're going to get our dx's with our x's and our y's with our y's. Perfect. Go for it, but you might run into a bit of a brick wall, and that's going to be a problem for you, so that's not going to work out. So we're going to try substitution. Now, to introduce it to the substitution, I'm just going to try and slightly adjust how we did it last week. Last week we started just by dividing everything and then simplifying. But what I'm going to say here is we're always going to let v equals y over x. Look, that's always going to be our aim. So before we do anything else, let's find out what y is equal to. Y is equal to x comes up to multiply vx. So the first thing I want to do is everywhere I see y, I'm going to replace it with vx. So dy dx is equal to x plus 3vx all over 2x. Okay, I'm absolutely fine with that. Now we can simplify. Now the easiest thing to do to simplify that fraction is you notice that x appears in absolutely everything. Now if you divide every single part of a fraction by the same thing, it makes life easier. So what I'm going to do now is divide everything by x. So x divided by x is 1, 3vx divided by x is 3v, and 2x divided by x is 2. Okay, now nearly ready to go, except I've got dy here and dx. dx is fine because I'm happy with my x's. It's my dy's. I have no more y's. Instead, I've got v's there, so I need dv dx. So we're going to come back up to this and we're going to adjust it. So if I have y is equal to vx and we differentiate the y, we get dy dx. Now, differentiating the right hand side, it's a chain rule. So u times dv dx plus v times du dx. So your u here is at v. So v times the derivative of x, which is 1, plus x times the derivative of v. In this case, we're going to call the derivative of v dv dx. If for no other reason, we need a dv dx. Now, everywhere I see dy dx, I can now replace it with v plus x dv dx. So v plus x dv dx is equal to 1 plus 3v over 2. Okay, so now we've got a situation with dv's, dx's, and no more y's or anything like that. So we can simplify this fraction and get our v's with our dv's, our x's with our dx's. First thing we do is multiply everything by 2, just get rid of the fraction, plus 2, and then v plus 2x dv dx equals 1 plus 3v. Now I might start moving stuff over, so I have 2x dv dx. Now I'm going to bring 2v over, so it becomes minus 2v, so it becomes 1 plus v. Alright, nearly there. So now I'm just going to get rid of this dx underneath the line and see what it looks like. So dx is dividing, so when it comes across it'll multiply. Okay, but that doesn't quite work because I need my v's with my dv's, not the other way around. But 2x is multiplying, so when it comes over it divides, and 1 plus v is multiplying, so when it comes over it divides. So dv over 1 plus v is equal to dx over 2x. Perfect, now I can integrate both sides. Okay, so the integration of the right side is easy. I'm just going to pop the half outside. And the integral of 1 over x is the natural log of x. Okay, going to have a look at the integral of the left hand side here. Now, we discussed the last day that that's just going to be the natural log of 1 plus v. Let me just do a quick aside, and I'll only do this once just to remind you why that is. So I've got the integral of 1 over 1 plus v. So what I do is I let u equals 1 plus v. So then du dv equals 1, du equals dv. Sorry, I should have a dv up here. So I can replace it as 1 over u, and I can replace my dv by du, which is just the natural log of u, which of course is just the natural log of 1 plus v. Alright, that's your explanation there. We're nearly ready to go, so what I'm going to do is just simplify out a little bit. I've got a half here, so if you've got a number multiplying a log, you can bring it in front to be the power. So I've got the natural log of x to the power of a half. Okay, that's the square root of x. We'll deal with that in a second. But now all I've got is 2 logs on both sides, so I'll get rid of my logs, and I just have 1 plus v is equal to, let's call it the square root of x, x to the power of a half. Now let's bring back in what v is. V is y over x, so y over x is equal to root x. Okay, so to get y in its own, I'm going to multiply everything by x. Now 1 by x is x, y over x by x is y, and I get x root x. Okay, so y is equal to x root x. minus x, and then plus c at the very, very end.